scatter graphs. In today's lesson, we will be looking at scatter graphs. We will be looking at plotting scatter graphs, what scatter graphs look like. We will be looking at the word correlation, what the word correlation means, and then we'll be looking at a scatter graph to see if we can answer some few questions regarding the scatter graph. So let's have a look at an example then. So let's say that in the classroom, in your form class, the teacher's asking you, what is your dad's shoe size? Okay, so we're just going to say size here, and let's have a little table. Okay, so the sizes are, these are the sizes given to us. We've got 5, 12, 7, 10, 10, 8, 9, 11, 6, and 8. Okay, then she says, what is your dad's weight, which is mass? We can have 65, 96, 66, 93, 75, 72, let's say this one here is 90, shoe size 11, I'm going to say 87, 6 is 72, and this one here is 82. Okay, we have to plot this on a scatter graph. So to do that, we need to have an axis. So let's draw one out. I'm just going to zoom out a little bit. And I'm going to get myself a ruler. Just going to draw myself a nice big axis, so I've got plenty of space. Okay, remember, this here, if I zoom in, is your x-axis. Zoom out, that here is your y-axis. Okay, so obviously we need to have numbers in our x-axis and y-axis. We'll have a look. Right, so the shoe sizes are ranging between 5 and 12. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I couldn't go off in twos because I don't think I've got enough. 13, 14, 15, 16, 17, 18, 19, 20, 21, 20. No, I don't have enough. That's fine. So what I'll do is, don't really need all that, do I? So I'm just going to leave it at that, and I'm just going to write X there. Okay, the mass now. Okay, so the mass there is ranging from the smallest is 65, should we say, all the way to the highest one, which is 96, I can see. Okay, so I'm just going to go up in tens, hoping that's okay. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and we'll set 100 there. Okay, so I'm just going to get, sometimes you might have to adjust your line. Okay, and let's write the numbers in. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so plotting the straight line graph then. Let's plot our straight line graph. With somebody who has a shoe size of 5 has a weight of 65. So let's write shoe size here. So size, and make sure we write mass on the other side so we know what it is. Okay, and should we put some units on there as well? So we'll say the mass is in kilograms. Yeah. Okay. So somebody with a shoe size 5 has a mass of 65. So I'm going to go 5 all the way to 65, and I'm just going to put a little cross. Shoe size 12 has a mass of 96. So 12 and 95, 96 will be somewhere there. It's 7 and 66. So 65, 66, somewhere there. 10 and 93. 10 and 75. 8 and 72. 70, 72, somewhere there. 9 and 90. 11 and 87. And then 6 and 72. And 8 and 82. Okay. Now this is known as a scatter graph. And you can see probably why it is known as a scatter graph, because you have points here that are scattered on your graph. Now we don't join these graphs up to make a straight line, and we don't join these points up to make a dot-to-dot diagram or something like a frequency polygon. They just stay as they are, and that is a scatter graph. Now there's a few things that we need to know about a scatter graph, so let's have a look at some things. You will be asked about correlation. There are 3 types of correlation. So I'm going to draw 3 small kind of graphs here to just demonstrate what is a correlation. Okay, there we are. Move it across. Okay, I'm just going to get rid of this bit. Don't need this bit. Okay, so I'm going to just these are my scatter graphs. I'm just going to plot some points on there. Just going to get rid of that one. Okay, this next one. Okay, right. So these are 3 scatter graphs here, and we need to describe correlation. Well, there are 3 different types of correlation which you will be asked in your exams or your assessments. The first one here is where the lines are going upwards. One of the most common questions is, well, how do I know that the lines or the points are going upwards? Well, in the English language, we read from left to right, don't we? So we're going to start from left to right. So if you start at left, which is here, and you find your first point, and then you see, oh, the lines are going upwards. If all your points are going upwards, if that is the case, it is positive correlation. And we'll discuss in a minute what that means. If here again, English language, we read from left to right. So start from left, find your first point, up there or there, and then up, the other points are going downwards. They're not going upwards, are they? They're going downwards. That is negative correlation. Okay. These points here are scattered everywhere. So that means no correlation. Now the word correlation means relationship. Okay, what type of relationship? Positive correlation is as one thing increases, the other thing increases. That's why the points are going upwards. However, negative correlation is when one thing decreases, the other thing is increasing. And no correlation means there's no relationship between the 2 things at all. So you need to know the correlation and the points on your graph to work out line of best fit, which we need to do as well. So let's have a look at line of best fit then. Now, to draw your line of best fit, you've got to go through as many points as you can. And ideally, the best line of best fit is when you've got the same number of points, or I would say similar number of points above the line than below the line. Okay, so should we have a look at some then? Let's have a look at the first graph that we've drawn here and see if we can draw a line of best fit. I'm just going to change my color to red because that was different. You need a ruler, and all you need to do is, now your line of best fit here, let's have a look at what it's going to look like. Now, some people think that the line of best fit needs to go through 0. That's not the case. You have to go through as many points as you can, and having kind of a similar number of points above the line than below the line, and that can get quite tricky. So I'm going to try and just play around with this. Sometimes you just got to play around with it. I think, oops, that moved out of the way. I think if I do this, I've got more points below the line. So I've got to try and get it in the middle. And if I try and put these 2 points here, let's just have a look what happens. Okay, and then we can decide together. So it's going through that point and that point and that point kind of. So I've got 1, 2, 3, 4 points above the line and about 1, 2, 3 below the line. So I would say that's a good line of best fit. Okay, the line of best fit means you're kind of following the trend or finding the trend. And we need the line of best fit because we need to answer some questions using the line of best fit. And we can do that here. First of all, let's write down the correlation when we can see that the lines or the points are going in an upward direction. So we would say that's positive correlation. And then let's have a look at answering some questions by looking at our graph. So we've drawn that. Let's find here now, if I write the question out here. So we need to find the mass of a man with shoe size 11.5. That's your first question. Your second question is shoe size of a man with a mass of, let's have a look on here. What can we say? With a mass of 55 kilograms. So we need to use our graph now to work out these few questions. Well, the weight of a man with shoe size 11.5. So 11.5, find 11.5 on your shoe size. Oh, let's not do that. There we are. So let's just move this. 11.5 is right in between 11 and 12. Okay, there we are. This way here. Oopsie daisy. Let's try and get there. So it's better if you've got a if you're doing it on paper, because we'll just do that here. Okay, so 95, 96, I'm going to say that is 96 kilograms. So we're predicting. So we're predicting that using this trend of data, if a man has a shoe size 11.5, his weight would be 96 kilograms. That's not for sure. This is just a prediction. That's what we are predicting. Then we need to predict the shoe size of a man with a mass of 55 kilograms. So let's go to the mass, which is here. Find 55 kilograms, which is here. And you go all the way up to your line of best fit, which tells you the trend basically of this data, and we can predict different things. And then I'm just going to read down, and what do we get? Oh, 3 and a bit. So what could we say? You can't have 3 and a bit of a shoe size, can you? So ideally, should we just say 3? Yeah. If I'd done this a bit less, if I'd done this as like 50, I don't know, 4, or even a bit less, 52 kilograms, you would have got like an exact answer. But you could say 3.2 if you want to be exact. Should we just do that? I know we can't have 3.2 of a shoe size, but if we are doing this exactly, then we would write 3.2. Okay, and that is what a scattered graph is, where you use some data, you plot it on your graph, and then you determine the correlation, and then you draw the line of best fit, and then you can use that to work out different things and predict different things. We also looked at what correlation is, positive, negative, and no correlation, and we looked at drawing the line of best fit. Should we have a look at another example then? We'll do a quick one. So we have hours of sunshine and rainfall. Okay, so let's get the ruler out. Let's look at the relationship between hours of sunshine and rainfall. If I try and move my ruler about, which I can now. Okay, so hours of sunshine. Let's say we have 8 hours, 7, 8, 5, 4, 7, 6, and 9. We're going to say we've got 2, 3, 1, 9, 9, 1, 6, and 2. Okay, and that's in millimeters. How many rainfall did we have? So let's plot this on our graph then. I'm going to just zoom out. So I've got enough space here. Let's go upwards. Okay, let's get rid of that. So let's have hours of sunshine at the bottom. So I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Erase that. Oops, let's go back to it. X, and we're going to set hours of sunshine. Okay, next one. If I look back here, we need to go rainfall again. So same. So I'm just going to do 1, 2, 3, 4. I don't think it's going to fit on. 5, 6, 7. We need to go up to 9, so it's not going to fit on. Let's draw that back in. Let's just go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and rub that top bit off. Okay, and that's why. Let's plot our points then. We have 8 hours of sunshine. We have 2 millimeters of rainfall. 7 and 3. 8 and 1. 5 and 9. 4 and 9. 7 and 1. 6 and 6. And 9 and 2. There we are. So first of all, what type of correlation? Well, if we start from the left, find our first point up and the others are going down. So we were going to say it's negative correlation. And then we're going to try and draw a line of best fit. So you get yourself a ruler. And you remember, try and go through as many points as you can. Let's have a look. It's quite hard to go through them and they're a bit spaced out. So let's have a look. I've got 1, 2, 3, 4, and I've got 2. Let's try that again. I'm gonna have 2. Maybe this one's better because I've got 2 points here and I've got 3 points on the other side. So that's a better line of best fit. And there you are, negative correlation. There are the 2 types of correlation there, positive and negative, that we've done. We've drawn the scatter graphs as well. We've looked at what the word correlation means. Here in this situation, it means if you have more hours of sunshine, the less rain you have. So hours of sunshine is getting bigger and the rain is getting less. So that's negative correlation. The above one, if your shoe size is more, your weight's also going to be more. So if your weight is more, you're likely your shoe size is going to be more. So if one thing's increasing, the other thing is increasing. So in this situation, if your shoe size or your size of feet are increasing, your weight is also increasing. And that is what positive correlation is. Thank you for watching. Hope it was useful. Thank you.